So first off, the top piece there, what is SUSE Virtualization? What is the Harvester project that it's based on? First off, it is a type 1 hypervisor, okay? So it does virtualization. It is based on KVM. There's a bunch of different technologies in there which make it cloud native, including something called KubeVirt. But fundamentally, the VMs run on KVM, which is one of the 2 biggest hypervisors in the world. It's used by the largest hyperscalers and is extremely well trusted for both performance and scalability. Secondly, it is an HCI platform. It's hyperconverged infrastructure. It not only virtualizes, but it aggregates all of the storage, the networking across the hosts into clusters, into cluster resources that the VMs can be placed on, and it provides management for the hosts, the storage, and the networks. And then thirdly, it can also be used as a bare metal platform for container workloads as well. And this is really where I kind of come to the bottom row of things here, where I kind of explain what makes SUSE Virtualization, what differentiates it, what is kind of USPs, if you like, what makes it a little bit unique. How do you compare it to other virtualization solutions out there? Because there's a lot of virtualization solutions out there, and all of them can run VMs quite competently for the most part. Do you know what I mean? So it can be a difficult thing when you kind of try and compare one to another. And for me, these are the sort of 3 probably the most important things that stand out. First off, we focus really heavily on those customers, those with workloads that span both VMs and containers. It's kind of one of our primary sticks. We don't want to be a vSphere replacement. Okay, we absolutely can. We can run VMs and we can do a bunch of stuff that vSphere can do. But vSphere has been around for 20 years. It has a laundry list of features, and we are less interested in changing every single feature that vSphere has. It's not really what our main focus is. We want to be able to provide a platform that can run VMs and containers together, because we actually want to get our customers onto cloud-native technologies. But we appreciate that some of you have to get off your existing virtualization platform to get there, but are not ready to modernize every app on day one. Some of those VMs, it takes time to actually modernize them. It takes time to rebuild them. Some of them, you probably don't even want to modernize. You're just going to sit there, it's a pet, and it's going to sit in the corner and run until it dies 20 years from now. So we want to provide that virtualization functionality. I mean, if I can, ideally I can put myself out of job, because I enable you guys to get all of your apps off VMs in 10 years' time, and then I can retire. I mean, that's my plan. So as much as I love virtualization and have been in that space for the last 15 years, I actually want to make you successful at getting off VMs, if that makes sense. Secondly, it is a scalable enterprise solution. And what I mean there is to differentiate SUSE Virtualization against a lot of the other platforms out there. It is run by an enterprise company that provides you 24/7 support, that is trusted for products that have been around for decades. And that is not the situation that you get with all of the different virtualization solutions out there. And then lastly, it is fully open source. And I genuinely think that there isn't another virtualization solution out there that is as open source, if you like. Everything that we do is in GitHub. The roadmap itself is actually published and edited on GitHub, and it's where I go to get updates to the roadmap. In fact, it usually gets updated, to my chagrin, it normally gets updated there before the engineering team tell me. So, we really do this stuff all in the open. All of the extra tools that we have, the enablement, is done there, right? And that is not true of any other vendor that I know of. And I'm not mentioning other companies' names, but most of the other solutions out there that say they're open source, the bits of them are open source, and bits of them are not, and bits of them are expensive. So Harvester as an open source project really is open. And why is that important? Well, one, yes, because we all love open source. But secondly, the reason that you're probably looking for a virtualization solution now is because you're on a proprietary one that's stiffing you today. Do you know what I mean? The last thing you want to do is then go to another proprietary closed system where you feel that lock-in. And what's the easiest way of avoiding lock-in is to use an open source product. So sorry, I wanted to pause on that slide, and I I can literally talk to that slide for about an hour sometimes if I want to, because I think it's really important, and it kind of helps explain where we're at with SUSE Virtualization. Okay, here's a kind of another look at what's actually included within the stack itself. Arguably, this really isn't important in a lot of ways. We use a lot of these technologies. I put it up here for interest's sake. Arguably, you shouldn't really care about much of this because it just kind of works. But to kind of peel back the layers, yes, we have Harvester, open source project there at the bottom. We use Longhorn project, which is a storage product for our hyperconverged piece of that. We run KVM and RKE2 to run both containers and workloads, and we do that through a layer, an abstraction layer called KubeVirt, which allows us to use Kubernetes-like API to address both VMs and containers. And then up at the top, we have something called the Harvester UI. So when you go to install Harvester, it comes as effectively like an ISO. It is very similar if you've ever installed ESXi. It's a very similar process to that. You have an ISO file, you mount it on the server, you turn it on, you answer about 5 questions like the host name, the IP address, the subnet mask, and what cluster you want to join. If it's a new cluster, you give it a name. And then it installs itself. If you want to add more hosts, you just deploy that and add them to the same cluster. The first host that you install this on, it will automatically start a service, which is the Harvester UI service. You don't need to deploy a VM, an appliance, a piece of software somewhere to run like a management node or vCenter, for example. It's automatically, it's there for the cluster. Every cluster gets a Harvester UI. And then on top of that is something else called Rancher Manager, which is obviously the management suite for Rancher. What that enables for SUSE Virtualization is the ability to see more than one cluster. So it's kind of that bigger window. And it also provides some additional functionality that we do at a Rancher layer because it makes more sense. Okay, so that's kind of like what it is and what the stack is. I just want to kind of point out what can you actually do with it. I briefly mentioned this. It's a busy slide, but the use cases for it are, first off, you can run VMs in it. Okay, that seems pretty obvious. It's a virtualization platform. You can install VMs, and then within the VMs, you install an operating system and you run applications. Great. You can also host containers within the VMs themselves. So deploy a VM, install an OS, run container software in there. That is one way of running the containers on this. And it's a popular thing for customers because it provides a certain level of isolation and the certain use cases behind that. And then the third one there, and I will point out, the third one there is Tech Preview. It's been in Tech Preview for a little while. It's going to be a little while more before we actually turn to GA. But yes, you can run containers directly on it. So it is a good platform for actually running containers. And then the last one is really just well, you can do that, but you can also do all 3 or 2 of the 3 all in the same host. So you're not limited to one. You don't deploy it for one reason. Okay, moving on. This is just me popping up. It has as I mentioned, Harvester UI. It's not the best image actually that I've taken there, but at the end of the day, you log in. A lot of people look at this and think, oh, this is KubeVirt, and you need to know a lot about Kubernetes to run this, and I just want to run VM. It provides a UI. If you're familiar with most other VM management tools, it'll feel reasonably familiar to you. You can log in, you can see your VMs, you can see the hosts, you can see the resources that are being used, you can apply, attach them to networks, you can look at storage, et cetera, et cetera. And this is just that concept of we plug into Rancher Manager. You can attach multiple virtualization clusters. You can also attach that. You can see your edge workloads. You can see your cloud workloads as well, all under Rancher Management Server. So it provides this kind of top-down view. There's a whole bunch of features in here, and I'm not going to step through all of them. It's not even an exhaustive list. It's difficult to kind of keep up to date. There's a couple of interesting ones, and probably the one that's most interesting, and I'll mention this a couple of times during the presentation, but probably the first bullet point. It's It runs on both x64, but also ARM now as well, and that's one of the new features I'm going to talk a little bit more about. But I think we are as far as I know, we're the only commercial virtualization platform that actually fully supports ARM servers and ARM workloads. So, but yeah, all the sort of usual stuff that you would generally find from a virtualization platform is there. Happy to answer any questions about any of them, but I'll step through it. And then one kind of last slide in this section, I think, is talking about how do you actually get from your existing virtualization platform onto SUSE Virtualization. We include a tool, it's called VM import. In the docs, it's a little bit difficult to find and navigate to, but you can search for VM import. And it's a tool that lets you basically pull VMs from either vSphere. You can point it either at a vCenter, or you can point it at an ESXi host directly. You can point it at an OpenStack, and it will import the VM. It will copy the VM across to SUSE Virtualization storage volume. It will transform the VM, i.e., it will put it into the right disk format. It will add in the equivalent VM tools, if you like, etc. It will do that for you. It's currently, as of today, it's a fairly basic tool. It does that. It doesn't come with all the bells and whistles. We know there's additional functionality that we want to add in there. We want to add more automation, for example, so you can do this sort of at scale. We want to add in warm migration capability, because at the moment you need to shut down the VM and then copy it, and if that copy takes a long time, so there's a lot of data, you got a lot longer outage, etc. So there are improvements that we can make, but there's also multiple third-party tools that are available. In fact, there was a presentation given yesterday by Cloudbase. They have a product that can do basically from import and export to multiple different clouds and different virtualization platforms as both sources and targets. And you can point that tool at SUSE Virtualization, both as a source and/or a target, so you can use that. And that does have the sort of, you can schedule things, you can do things much bigger scale, much more easily. Has a really nice user interface to it, et cetera, et cetera. So if you're moving a big environment at the moment, one of those third-party tools is a good solution. Yeah.
Is there a plan to add Hyper-V as an import source?
Honestly, probably not. Not in the short term, anyway. Do you know what I mean? I've only heard that request once or twice. It doesn't come up super often. But always interested in kind of use cases. So if you have a particular environment that you're looking at, it's there. Okay, I wanted to talk a little bit about the 1.5 release. 1.5 release is due out within the next few weeks, I'll say. March, April timeframe, March, early April. And there's a few new features in it, the 2 or 3 new features I want to talk about. So first one is labeled third-party storage for VM boot disk, which is very specific, but there's a little bit of history here. We have been adding support for external storage for a number of quarters, probably about a year now. And with current versions like 1.4, you can actually use external storage for certain disks. But with 1.5, we're basically adding support for all disk types. This is the one sort of remaining thing to fall, as it were. That's why it's labeled in that way, and that's where you'll see on the GitHub page if you look at it and you follow the tickets. But basically, the big news is that up till now, SUSE Virtualization was really depended on Longhorn, really depended on its HCI storage. But now we're going to support external storage arrays that you can put your VMs on. Now, from out of the gate, we're targeting iSCSI storage. We have customers that are using Fibre Channel today with this, with some success, but we want to do more validation around Fibre Channel. But certainly iSCSI is where we're kind of currently targeting. Yes, we're also interested in doing NFS at some point, but again, that's just another step down the road. You'll have heard, you'll have probably seen in some of the keynotes today, we also, to accompany this, we also set up a program where external storage systems can certify themselves against SUSE Virtualization. Now, if you have a storage system, particularly an iSCSI storage system that has a CSI driver that's provided the storage company, should effectively work with 1.5. Now, what functionality exactly they provide, it depends on the CSI driver, for example. But we want to make sure you give you a little bit more confidence that the storage system that you have, and that's why we're working with these vendors at the moment. We're working with other ones as well, but these are the kind of first four that were out the gate, as it were, and they're validating their systems against 1.5 just now. So, excuse me. Another one, I mentioned it earlier. We've been working with ARM in the UK quite heavily over the last 6 to 12 months on this. We actually came out with the tech preview for this 1.3, so it's been out for a while, this functionality. But we've been doing a lot of work upstream to push changes up into KubeVirt and make it, you know, our target is to have our 1.5 release as a sort of GA where we'll stand behind it. As I said, we have a few customers, but ARM in the UK themselves are using Harvester extensively in their test lab environments and stuff. And I think it's really an interesting direction. Do you know what I mean? There was a talk earlier today, actually, talking about the Ampere servers and stuff like that, and they went through a demo, and Alejandro was doing it with one of their guys, and they kept sort of saying, the interesting thing about this is it's not very interesting. It basically works exactly the way you would expect it to work, but it's working on ARM with all the potential advantages of running on ARM servers. Do you know what I mean? The very high core count, the low cost, the low power usage, the reduction in heat in your data, et cetera. So really interesting opportunity there, because like I think we're the only ones that are really doing it at a supported level at the moment. And this is, I wanted to talk a little bit about the upgrades. So some of the changes that we're making internally, this is something that really wasn't on our roadmap because it's stuff that we've been working towards and making process improvements internally and stuff. So it never kind of came up until a few weeks ago. It's like, we need to tell people about this. This is the sort of thing that's actually very interesting for existing customers. If you're a new customer, you probably care less about this because you probably look at it and go, well, this is the way it should work. But if you're an existing customer, this will be good news to you. So as of today, we have this kind of interesting situation where we get dragged along on the releases, and it's primarily to do with Kubernetes. So as I'm sure you all know, Kubernetes gets released 3 times a year. They don't allow for skip upgrades. You have to upgrade to every single version. Now, for a lot of Kubernetes deployments, that's maybe not such a big deal, but when it's integrated into your hypervisor and upgrading your hypervisor environment takes longer than just a regular Kubernetes one, this can be much more impactful. So we would step through all these versions as we went, trying to get the Kubernetes version up to date. We'd always be kind of chasing that. And also, environmentally, virtualization customers, a lot of virtualization customers tend to follow a slower cadence with their upgrades, I'll put it that way. It's less inherent to them to want to upgrade to the latest cutting edge versions. They're usually a little bit behind. But we're kind of forced our way through it. And we've been doing it, it's been 1.40, 1.41, 1.42, and it's not been very clear what's actually been included in those versions as well, or the timeliness of those. So we used to do upgrades, they were feature-based upgrades. So sometimes it would be 6 months apart, sometimes it would be 8 months apart, 10 months, sometimes we'd slip releases because we wanted to make sure the features landed in there, and it certainly wasn't something that you could kind of depend upon. So from 1.50 forward, so you're going to get yourself to 1.50, but 1.50 forward, we're going to make it much more prescriptive how this is done. And we're going to tie the Kubernetes components to each of those, what we call minor versions. So if you follow it X, Y, Z, it's the Y version that is going to get all the Kubernetes component upgrades. And this is the money one. And there's a lot of detail on here, and I'll step through some of it. But basically, yes, we're still going to do patch versions. So that Z release, we're still going to provide those. But we're going to offer a lot more flexibility. So first off, The minor versions, i.e. 1.5, 1.6, 1.7, we're now doing it on a time-based release schedule, so it's going to be every 4 months. That will allow us to keep up to date with Kubernetes, and it makes it really predictable for you guys when those things are coming out. And it also aligns to the rest of the Rancher suite, because the rest of the Rancher suite, including Longhorn, is all kind of aligning in this model. It provides, we're going to be providing a lot more flexibility there as well. So you'll be able to upgrade basically from any patch version to any patch version. So from 1.5.0, you'll be able to upgrade to 1.5.1 or 1.5.2 when it's available, or you can go straight from 1.5.0 to 1.5.3, et cetera. Or, you know, as long as it's a forward one, you can jump those patch versions. You don't have to install every patch version. And then when you're going between the minor versions, so you can go from any version of 1.5 to any version of 1.6. So again, you know, it gives you that flexibility. And lastly, with any of these patch versions, the patches included within them, they do accumulate up. So you don't have to step through every patch to get every hotfix. You just have to go to the latest one in that minor version and you'll get all of the patches. So makes it a lot easier to understand. We are going to try and keep all the functionality to the minor versions. So the patches are just going to be patches. There's just going to be CVEs and then sort of critical hotfixes, that type of stuff. So if you just want to keep yourself up to date, like we have a lot of customers in air-gapped environments where upgrading is difficult. Now they are less concerned actually about CVEs because it's completely air-gapped. So they don't have to step through any of these patches now, unless there's something like a bug in there, and if there's a bug identified that's affecting them, then they can apply that patch. They don't have to do any of the previous patches, they just apply that patch, and then they can sit on that, and then they can wait 4 months to get the next minor version where it will actually provide additional functionality. So it makes it really prescriptive, easier to understand, I think, and a bit more flexibility as well. As I said, if you're a new customer, you probably don't care so much about this, but if you're an existing customer, where you having been stepped through every single version that comes, it can be kind of hard work. So this is one of those kind of cool things. Oh, and lastly, the bottom line there is, I just want to point out, this has always been the case, but the XY0 release is what we kind of refer to as our community release. And it's what we generally, when we talk about dates, we talk about actually about the community version. We always customers back. So this microphone's really crackly. I'm going to try and move it down, hopefully that helps. We actually hold back, we used to call them stable versions. So it's the .1 and forward, we would call it stable. I think we're going to rename that to Prime, but it's basically, those are the ones that we recommend for our customers, because it's been through like, it's basically the first patch release afterwards. You know what I mean? So that's what we would generally recommend for our Prime customers. And just to kind of explain that a little bit more, so there you've got, you know, the 1x0 is the community one. It's kind of, you know, we provide those releases and they circulate every 4 months. We provide full support for customers for 6 months for that line, but then an additional 18 months for maintenance. So we can provide hot fixes and critical hot fixes and really high level CVEs as well for that full 18-month period. And then there's also, if you're part of the Rancher Prime, if it's a Rancher Prime LTS version, then it's extended out even longer as 24. And there's actually other programs beyond that, but it kind of it helps align things. So again, we're, you know, SUSE Virtualization, SUSE Storage, they're both aligning to this, which is aligning to everything else in the suite as well. So it makes it really easy to understand. Previously, all the different products had slightly different support contracts and support years, and it was rather complicated. So future stuff. How am I doing for time? Good for time. Okay, so here's the kind of roadmap slide. I'll spend a little bit of time. There's a lot of information in here. I'm not going to go through everything. So currently we're in 1.4, okay? Came out at the end of last year. Probably the one that's interesting there is the top one, Longhorn V2 data engine. Now, when I step into the storage section, I can talk a little bit more about this, but I'll explain it now. Longhorn has been around for several years, but the team for over 18 months now has been working on optimizing the guts of it, basically. And we have a new data engine primarily based around performance. that significantly improves the performance on modern hardware. We have that available as a tech preview and have done with the Longhorn releases for a few of the releases now, but we actually wanted to bring it into SUSE Virtualization so our virtualization customers could take advantage of it. It is technical preview. I wouldn't go installing your production workloads on it, but this is particularly useful if you're doing POCs and you're planning on using the Longhorn storage. This will let you see some of the improvements that we've made and on potentially what you can rely on in the future and stuff. So pretty interesting stuff there. What else in there? Volume encryption, a really key one for some of our customers. Remote storage for diskless servers. So this is basically boot from SAN. So you'll have seen from other virtualization platforms, boot from SAN, particularly for sort of blade servers where you don't have disks. You can assign a LUN and then actually boot the harvester system off that directly. So again, this was another step of the supporting external storage. It was just another kind of feature. We're now coming into 1.5, ETA Q1. It may slip, just creep into Q2. It's either going to be late March or early April, put it that way. Some of the key things there, I've already mentioned most of them. New release cadence, so it's going to be released now for 4 months going forward. Updating the Kubernetes components like we always do. Talking about the third-party storage, the ARM support, and then the volume encryption I mentioned earlier will actually go GA. Quite often with some of our features, we will introduce them as a tech preview, and then the following release we'll make it GA. And that's the usual sort of cadence, usually 1 or 2 releases before we get it to GA. Over on the right-hand side, so this is kind of a big bucket, and I haven't put 1.6 there. Not all of those things are going to land in 1.6, that's for sure. I actually wanted to have more stuff in there, so I kind of left off a version number. So these are features that we'll be looking at implementing. Hopefully most of them in the next 12 months, say, but I certainly wouldn't guarantee it. But those are sort of big things that we're looking at. And these are probably some of the interesting bits I'll talk through. So first off, improving the third-party storage experience. So we've got, as I mentioned, from 1.5, we're going to be supporting third-party storage. We're focusing on iSCSI, but clearly there's other protocols there that we want to start supporting, so we'll start adding that in. I also want to add more in the UI. So with 1.5, you won't see a tremendous difference. You'll just, you'll be able to implement third-party storage through the CSI driver. We want to actually provide more feedback in the UI. So you can see, multipathing, you can see different options in there. Dedicated networks, new CNI use cases. So with SUSE Virtualization at the moment, the virtualization aspect, the networking aspect is probably the least mature, in my opinion. Everything runs through Multis as a CNI. At the cluster, you can create virtual networks based on VLAN IDs, basically, and then you can attach your VMs to those VLAN IDs, and it can talk to the network. But we don't have super advanced networking set up at the moment. So the team's been working really hard. So as we kind of, we've done a bunch of work in storage, we really want to start providing additional networking capabilities. So we're looking at different CNIs that we're going to integrate into Harvester so you can get some of the capabilities. And some of those sort of things are, first off, cluster switches, so the ability to be able to manage your networking at a cluster level, provide that kind of switch view of how you manage your VMs and your hosts. VXLAN support, a very popular request to provide a network overlay and do some interesting things like DR and site awareness and stuff. Microsegmentation is another often requested feature, particularly for customers that come from the last two come from NSXT environment. Then we can provide that functionality. What else have we got down there? Virtual clusters and bare metal GA. So this is the one where I mentioned previously on the capabilities. Bare metal is that ability to run containers on the bare metal themselves. You don't have to install them in the VM. You can just use Harvester to actually run containers. We can do that today. It came out as a tech preview 3 or 4 releases ago, as a tech preview. preview. And as I said previously, normally within 1 or 2 releases, we flip it from tech preview to GA. We've not done it with this bare metal container support because we've been waiting for a couple of things. And one of the things we've been waiting on is the virtual cluster support that's coming into Rancher. So you probably heard about that this week. It just provides very strong isolation for workloads. So the reason why that is important is because we want to use that to help protect the cluster resources from other containers that are running there. So that's kind of what that's waiting on. There's a bit of a dependency there, that's all. So we have the capabilities to run bare metal containers. We want to improve the protection around it for the cluster itself. Other bits and pieces like storage live migration. When we used to, it was an HCI platform with Longhorn. We didn't really need storage live migration because the VMs weren't going anywhere because they were running in the cluster. Now that we've provided support for third-party storage, you're going to have like multiple targets for your storage. We need a way of being able to move the VMs from one piece of storage to another piece of storage while the VM is turned on. So that's what that is there for. We've always been aware of it. We wanted to get third-party storage out there, but now we realize we want to enable you to be able to move it between different SANs, for example. Okay, I will move on. Any questions about that? Because I think that's all the virtualization slides. Okay, yeah. Yep. No, that's a good point. If you're from 1.5 on, if you're connecting to external storage and you're moving all of your VMs there, in theory, yes, you don't need Longhorn. By default, when you actually install Harvester, when you install SUSE Virtualization on each of the hosts, it will grab the disks and it will create a Longhorn volume for you. You don't need to use it. I mean, that's the first and foremost. You know what I mean? And if your hosts don't have local disks, you do a boot from SAN, then Longhorn will not be set up, basically. The one area where this is important, though, is, and it's another enhancement that is not actually on the slide there, but it's something that we'll add soon, is at the moment when you deploy SUSE Virtualization, it reserves host resources for Longhorn. So basically, to protect Longhorn, to make it run well, it reserves a certain amount of CPU and memory for that. So one of the enhancements that we're going to be adding in a soon soon update will be the ability to sort of say, I'm not using Longhorn, stop reserving those resources on the hosts. So again, another thing we knew we have to do. We're just going to, now we've actually got external storage. That's one thing that we'll be doing. Okay, I'll keep moving on. Sorry, you have one question. Yes. Yeah. Yeah, exactly. That's the one that we're looking at. I mean, I can't guarantee it, but that's the one that we're looking at actively. There's a couple there that are more, there's a couple of the CNIs that are more Kubernetes focused and KubeVirt focused, I would say. The sort of 2 that's popular at the moment. But yeah, that's the plan, is to use that one. And I think it will provide pretty much all, most of the functionality. It lets us get these, because some of these are big ticket items that require a whole lot of work, but if we kind of base it off that, it provides a standard-based approach and we can get there much, much quicker. So, yeah. Okay. I'll talk a little bit about SUSE Storage. Kind of step through this. The first thing I want to point out is everything I've been talking about now has been to do with SUSE Virtualization, i.e. Harvester, that includes Longhorn as its HCI storage platform. I want to be really obvious about this, but that is one use case for Longhorn. It's not the only use case for Longhorn, and not the only use case for SUSE Storage. So when I talk about SUSE Storage here, I'm actually just talking about the storage product. Yes, it gets used in Harvester, but you can also just use it as a storage product for Kubernetes. Right? So not just virtualization capabilities. Think containers, think Rancher, think persistent volumes for Rancher. Then you have SUSE Storage. So I want to make sure we're kind of aware that it's not just Harvester I'm talking about here. So I mean, I'm not going to read through every item there, but yeah, it's Kubernetes centric. It has a nice, easy to use user interface. It's fairly lightweight. It works well. You know, it's a CNCF project. You know, it has been for a while now. Fully open source. Again, everything that we do around Longhorn is on GitHub. You know, it's available for you to see. You can raise issues there. You can see the progress. You can see the roadmap, et cetera, et cetera. So super quickly, you know, I don't want to get into the depths of necessarily how it works, but probably the one thing that's worth pointing out, it is not based on what you would traditionally think of as sort of hardware RAID technologies, for example. It's based on replicas. So, do you know what I mean? For a pod that you attach it to, there's a one-to-one mapping with an engine that sits in a host. Down at the bottom there, the diagram shows two physical hosts, a bunch of SSDs in them, CPU and memory. It will lay out replicas and spread them across the hosts depending on the settings that you set. So, you know, for each volume, you can set that replica to be, you know, 1 replica, 2 replicas, 3 replicas, whatever you want. You can force it to sit on one physical host if the application itself is spread across nodes and you don't need to worry about replication across the host, for example. Do you know what I mean? You can set it just for local, set it to be local and set it to be just 1 replica, for example. Or you can use, you know, Longhorn to push those replicas across multiple hosts, and you can set up anti-affinity so that they don't all sit at the same host at the same time. Fairly straightforward, you know what I mean? And everything, if you think about how we do storage in that regard, then it kind of explains how things work effectively. Okay, a bunch of details there about deployment options. Again, I'm not going to step through all of them, but yep, it's x64, but also ARM as well. It'll work in ARM. You can use Longhorn for any Kubernetes distros out there. There's a bunch of ways you can install it through Rancher with a Helm chart. You can use a range of different GitOps options. It comes as part of Harvester's HCI, but you can use it with other Kubevert integrations, for example. So, coming back to the release cadence, a lot of what I just mentioned for SUSE Virtualization actually applies here as well, even though they are separate products. But yeah, we're moving to a 4-month cadence. We're currently 1.8 is the release that's out at the moment. You know, but we're stepping through 1.9, 1.10, 1.11, 4 months apart, and that's the schedule. If you ever want, just, you know, Google Longhorn roadmap. It'll have the dates, or at least the months, with the dates for each version, with an update on what's included. Bunch of functionality there. Again, I'm not going to step through all the functionality, but, you know, at the end of the day, you know, thin provisioning for the volumes. As a way of saving capacity, basically. It allows for snapshots via copy and write. You know what I mean? You can live update the system by, you know, and it will migrate and ensure that there's replica copies during the upgrade. We have a bunch of, down at the bottom there, we've got the V1 and the V2 data engines. I mentioned them earlier in the context of SUSE Virtualization. I'll talk a little bit more about that. It's got a UI, you know, has a bunch of anti-affinity for the disks, the nodes, the zones, et cetera, et cetera. There's some data protection options that are already included, and we're adding more, and there's a bunch of services. So this is an interesting one. So I talked about V2, the V2 engine. When we talk about the V2 engine, it is almost all around performance. You know, that is the primary driver for us working on and building the V2 engine. And you should think about it in that regard. Ignore the middle column, because we're probably not going to actually provide that. Basically, the left-hand column there is what is currently available as the sort of GA Longhorn release. And those are some of the sort of metrics that we did this about. This has been around for 3 or 4 months, these metrics now, in a setup, and you can read how it was actually configured there. Both for reads and writes, you know, and across IOPS and bandwidth and ensuring the latency. With the V2 engine, these are sort of some preliminary results. The middle section, by the way, was just an enhancement that we were going to apply to the V1 engine to sort of help us a little bit. We're actually just going to go straight ahead. We want to get to V2 as quickly as possible. We want all our customers to take advantage of V2 as quickly as possible and be stable as quickly as possible. So we're going to miss out that whole section and just get to V2 quicker rather than delay things. But you'll see there in the test results that we have, and obviously, these are test results of a somewhat synthetic configuration. Your workloads will differ. I can't guarantee this is necessarily the performance that you will get with every single workload that you have, but we have to test it somehow, and we have to try and prove that it is becoming worthwhile. But you'll see in every angle, whether it's reads or writes, it increases the IOPS. Do you know what I mean? You're getting much more bandwidth. You're getting, latency is cut down significantly. You look at the IOPS, for example, it's a factor of, it's a whole factor that's out. You're talking 10x in most of these things. So it is a significant performance improvement. And that's what we're looking at. And that's the reason why we've been including it as a tech preview, even within Harvester. It's not put production workloads in it, but it's such a big step up that it's worth kind of getting your hands on. And I want you to be aware of why we're focusing so much effort in getting to this as quickly as possible. Okay, moving on. Oh, and we're into the roadmap here. So I'll talk a little bit about, okay, we've got a couple of minutes here. So 1.8 is the version that's out at the moment. So a big part of the sort of roadmap at the moment that you really see is us moving basically, the thing that's holding us back from saying that V2 is GA is not actually the engine itself. The engine has actually been worked on for a couple of years now. And it's actually extremely stable, and it performs really well. And arguably, why wouldn't we just give it? Why wouldn't we tell customers to use it right now? And the reason is not because it's not stable and it's not production ready. It's because all of the functionality that's currently in Longhorn with V1 is not available in V2. We have to go back through and look at every single piece of functionality that we've built and get it ready for the V2 engine. And that is where over 90% of our development efforts are focused at the moment, is getting all the functionality that you currently expect from Longhorn and making it from day one available on the V2 engine. So again, I'm not going to step through, but if you look at 1.8, most of the features there, they're already stuff that's in Longhorn. These are not new features. They're just getting ready for V2. There's a couple of things we haven't completely ignored. The V1 and our current customers, as it were. We're trying to make small, you see there, small performance improvements. Multiple backup stores, for example, we used to only support one backup target. You can now actually go in and point at multiple different backup targets, if you like. The ability to install, we've got the Helm charts. You can now use the Helm controller that's in K3S RKE2 to deploy Longhorn. The middle one, coming out fairly soon, in the next couple of months. Top thing there, available via application collection, so AppCo is kind of colloquial, we call it internally. You'll have seen presentations, hopefully, the new Rancher application collection tool for deploying applications. You're going to be able to actually install Longhorn via that very shortly as well with 1.9. And then there's a bunch of this, yes, more features, getting it ready for V2, great. And then the last one is the one sort of tip for the scraps for the existing customers. We've had the ability to do system backups for a while, but now it's like, we have a recurring scheduler for that. We're adding that back in. And then over on the right-hand side, some of the bigger stuff that's coming. So obviously the big thing, as I mentioned a whole bunch of times, is getting to that GA for V2. At the moment, and we have this publicly, the version that we're looking at targeting is, if I can count properly, I think it's 1.11, which is due in January. That is when we're currently targeting to release the V2 engine as GA. And we will pick that up in Harvester shortly after that. Do you know what I mean? Probably the next release. I assume it will be the release following it, which will probably be March next year. So that's the sort of time frame that we're looking at. Nothing in storage happens super fast. Do you know what I mean? They are, storage has to be rock solid. Do you know what I mean? You can move faster in other areas, but storage is one area you don't want to move too fast. You want it to be as rock solid. So that's why it's taking a bit of time. The second point there, the V1 to V2 volume migrations. So don't assume that necessarily that's included. That is very much a separate feature. We will probably initially provide a way of being able to do cold migrations, for example, and then we'll be looking at warm migrations and in-place upgrades, et cetera, et cetera. So we have a bunch of different options there that we'll provide. Sharding, that's sort of the biggest feature that we've been asked for the last couple of years, and we've been putting it off because we wanted to get to the V2 engine. So we're actually going to be including that. I think sharding will actually land GA when we do the V2 GA at the same time, because we've been pushing so hard for it. It basically the ability to spread individual files across multiple replicas, because at the moment one of the limitations around Longhorn is that the biggest object that you can save on the volume can only be as big as the biggest disks you got in the underlying storage, because it can't span multiple disks. So big one. It's basically a capacity constraint at the moment. Volume groups, there's a whole bunch of functionality we want to do around volume groups, make it easier to operationalize and manage. Some throttling, and IPv6 is something that we occasionally get asked for. It is something that we want to do. It's just a case of doing it, and it's just another one of those things that we have other priorities at the moment, but we do want to get there, so we kind of recognize that. And with that, I think that is the last slide. Just want to say thanks, everyone. I'll close out the talk there. I'll wait around for a little bit longer. If you have comments or questions, come and grab me either just now or later on in the show. If you want to have a meeting with me about SUSE Virtualization and SUSE Storage, talk to your rep. We'll get it organized hopefully this week. If not, we can do it offline even. But yeah, thanks everyone.